15 minutes or so. So if you look at the 9 billion person challenge and the CO2 challenge, it turns out that although I said, you've got 3 basic choices, first off, you probably don't want to be in a position where you rely on any one of those because we can't be certain that any of them will really work at this point in time. We don't know if we can make fusion feasible. We don't know if we can solve the problems of intermittency associated with a lot of the renewables. We don't know if we can solve some of the challenges with fission, particularly in terms of public acceptance and cost. So the smart thing to do is to hedge your bets and make progress across a range of different sorts of activities. And sometimes the best way to solve a really big problem is to break it into a bunch of smaller problems that you can individually solve. And so if you look at what the elements of things that we should be working on are, they fall into a couple categories. The first is one that I haven't really talked about much except when I talked about GDP, and that's just really improving energy efficiency. And in the near term, in the next 5 to 10 years, the biggest impact we can have is this area here. Energy efficiency has a bunch of advantages. The first is that you actually get paid to do it. McKinsey did a study of CO2 emissions, and their analysis showed that if you look at the amount of CO2 emissions we need to reduce or avoid in order to not get into a really uncomfortable climate change position, about a third of those avoided emissions came at negative cost. So it didn't cost money to avoid the emissions. You got paid to avoid the emissions, and that's because they were all energy efficiency. And it cuts across transportation, buildings, industry, electricity, the whole range of things. Electrification of transportation is important because it's really difficult to imagine sequestering CO2 at an industrial scale. It's totally impossible for me to imagine sequestering CO2 on the tailpipe of every car. So in order to have any hope, you've got to electrify transportation so that you can have some kind of either clean energy supply in the form of renewables and nuclear, or kind of industrial scale sequester of CO2 at the generating station. And so electrification of transportation is important because that's the only way you're going to have emissions-free transportation that I can think of. Renewable, I talked a bit about. Biofuels, which is another element of renewables. This is important also not just because of fuels, but petroleum is important to us not just because of gasoline and diesel fuel. Petroleum is the feedstock, for the chemical industry. It's plastics. It's actually natural gas is fertilizer, and so when you look at biofuels, you need to look more broadly than just the fuel because all of those things have CO2 emissions associated with them, even if it doesn't turn into a fuel that you burn. Advanced liquid fuels from fossil resources, this is one that's actually got to be coupled with carbon management, but in terms of energy supply, if you're concerned about petroleum and the available petroleum resource and petroleum prices, you can make liquid fuels out of natural gas, and you can make liquid fuels out of coal. So that's workable. Of course, you've got to worry about the CO2 emissions. So this one has to be coupled with carbon management in some form. And then finally, the next generation of nuclear power, it's fission and fusion. So making progress across this range of activities is probably the best approach. And the way people tend to talk about progression of research from fundamental research through applied research to eventual deployment is this sort of linear model. This is something that people like Vannevar Bush at the end of the Second World War, who was an American policy expert, talked about. The motivation for making public investments in research all had to do with this kind of linear projection from fundamental discoveries, observations, and predictions through figuring out how to turn these into new processes and characterize what's going on, model it, and then eventually kind of fabricate and test prototypes of things and simulate their behavior to the point where you can really demonstrate and eventually scale up. Now it turns out this is a great model, but it really doesn't have much to do with what's going on, because first off, there may be things that you would like to do over here that you don't even realize are possible until a discovery reveals them to you. So there are many instances where basic research has to reveal things that can then give you the idea that there may be some new opportunity. And also, things never go in a straight line, so you run into problems, you run into bottlenecks, and sometimes you've got to go back and do some real fundamental science in order to solve them. So this progression is actually a much more complicated, messy thing, and probably should be drawn as all kinds of curlicues and dead ends and so forth. It's not this sort of straightforward, okay, I've got the science and now I'll just scale it up and go to market. So let's now concentrate, go through that list that I gave you and ask the question, what are the prospects and needs? So if you look at energy efficiency, as I said, this is the low-hanging fruit. And this shows the world energy consumption by end use. About half of energy is consumed in industry. So obviously, industrial energy efficiency has a big impact. 20% in transportation, 18% in residential, and 12% in commercial, in shops and that kind of thing. So most of these two are electricity. A good chunk of this is electricity, but not all of it. And of course, most of this is at the moment petroleum. But all of them benefit from improvements in energy efficiency, and some of them are listed here. High efficiency appliances, and things like using heat pumps instead of air conditioner, hot water heaters, for example. You can use heat pump hot water heaters. They use twice as much, or half the electricity as a resistive hot water heater. Refrigerator efficiency has improved by a factor of 3 over the last 40 years. And there's still more efficiency that can be wrung out. There's a lot of wasted energy in the distribution system. And just getting more efficient distribution and dispatch could have a big impact. High efficiency vehicles, there's a push to go improve the fuel efficiency standards worldwide. In the US, we're going from 25 miles per gallon average fuel efficiency to 55 miles per gallon by 2025. That you can do the math on what that does in terms of your energy consumption. There's a lot you can do through building codes for new construction. There's a lot of buildings that already exist, and so building codes won't help you with those, but retrofits can improve the existing building stock. And since industrial energy consumption is such a large part of the pie, improvements in industrial processes can make a big difference